Welcome to this lesson on IAM roles. In this video, we'll explore one of the most important security features in AWS, IAM roles, and how they provide temporary security credentials. IAM roles are essential for secure access management, allowing services, applications, and users to interact with AWS resources without storing permanent credentials. Let's dive in and understand how roles work and why they're critical for AWS security. An IAM role is an AWS identity with specific permissions that can be assumed by AWS services, applications, or users. Unlike IAM users, roles don't have permanent credentials such as passwords or access keys. Instead, when you assume a role, AWS provides temporary security credentials. These credentials are automatically generated and rotated by AWS, which significantly improves security. Think of a role as a hat that someone can wear temporarily to gain specific permissions, and once they're done, they simply take off the hat. Every IAM role consists of 4 key components. First, the trust policy, which defines who is allowed to assume the role and specifies which principals are trusted. Second, the permissions policy, which determines what actions the role can perform on AWS resources once it's assumed. Third, the session duration, which sets the maximum time that temporary credentials remain valid. And fourth, the role ARN, or Amazon Resource Name, which is the unique identifier used to reference and assume the role. These components work together to provide secure, time-limited access to AWS resources. Here's an example of a trust policy that allows an EC2 instance to assume a role. The policy has a version field set to 2012-10-17, which is the current policy language version. The statement contains the access rules. The effect is set to allow, meaning we're granting permission. The principal section specifies that the EC2 service, identified by ec2.amazonos.com, is trusted. The action is STS::assume role, which is the API call used to assume the role. This policy essentially tells AWS that EC2 instances are allowed to take on this role and use its permissions. IAM roles have 3 primary use cases. First, AWS service roles, where services like EC2 instances, Lambda functions, and ECS tasks use roles to access other AWS resources securely. For example, an EC2 instance can assume a role to read from an S3 bucket without storing access keys on the server. Second, cross-account access, which allows users or services from one AWS account to access resources in a different AWS account. This is crucial for organizations managing multiple accounts. Third, federated users, where external identity providers like single sign-on systems, SAML, or OAuth can authenticate users who then assume roles to access AWS resources temporarily. Let's understand the role assumption workflow. First, an entity such as a user, service, or application requests to assume a role. This request goes to the AWS Security Token Service, or SDS. SDS then validates the request by checking the trust policy to ensure the entity is authorized to assume the role. Once validated, SDS issues temporary credentials, which include an access key, secret key, and session token, along with an expiration time. The entity can then use these temporary credentials to access AWS resources according to the permissions defined in the role. When the credentials expire, the entity must request new ones if continued access is needed. Here's an example of a trust policy for cross-account access. This policy allows another AWS account to assume the role in your account. The structure is similar to the previous example, with version set to 2012-10-17. The principal section now contains AWS instead of service, with the value being an ARN that specifies the root of account 1234567899012. This means any identity in that account, if properly configured, can assume this role. The action remains SDS::assume role. This type of trust policy is fundamental for implementing secure cross-account access patterns in multi-account AWS environments. IAM roles provide 5 major benefits. First, enhance security through temporary credentials that expire automatically, reducing the risk of credential theft. Second, there's no need to embed or distribute long-term credentials in your applications or configuration files, which is a common security vulnerability. Third, AWS automatically handles credential rotation, eliminating manual rotation processes and reducing operational overhead. Fourth, roles enable granular permission control, allowing you to implement the principle of least privilege by granting only the permissions needed for specific tasks. And fifth, roles simplify cross-account and federated access management, making it easier to collaborate across organizational boundaries securely. These benefits make IAM roles a cornerstone of AWS security best practices.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.